Okay, I think I'm just going to get started. Just make sure one more time. I think my mic is on. Okay, so I'm just going to get started. We're going to go over the geometry January 25th, 2023 Regents. And I'm going to do so as efficiently as I can while trying to get to everything. However, I do want to like scroll down here and show you guys something. Keep in mind the scores. You can see how many points you get for each question and stuff like that. But you could see to get a 65, a minimum grade of 65, for this test at least, you needed 32 points altogether, right? So you can see like, I guess you could get 80 points altogether. I don't know. I never really checked it up like that. But if you get 32 points, you will get a 65. All right. So that's really how that works. Let's start. Okay. Question 1. In the diagram below, a line reflection followed by a rotation maps this triangle onto that triangle. What statement is always true? Okay, so if you're doing a series of rigid motions, reflections and rotations are both rigid motions, which means that they don't change the size of the shape, the angles, everything about it remains the same. If that's the case, then matching pieces would be congruent. So we just have to kind of see which pieces match. Now, the way that they wrote the triangle actually matters because the point A actually gets mapped onto point D, right? So this point is actually ended up right there. So that means B, which I'll put like a little plus sign by, ended up where E is. And then finally, F, I'll put a single angle mark there, is really where C ended up. C ended up where F is. All right, so using that, let's match the sides up. What statement is always true? BC, so that's the plus sign to the single angle mark, is congruent to EF, the plus sign to the single angle mark. This seems to be true. I'm just going to put a little dot right there. Let's check out the other choices just to make sure. AC is congruent to DE, so that's a dot to the single angle. DE, nope, it's a dot to the plus sign. So I know this one is not true at all. They want to know which one is always true. Angle A congruent to angle F. Angle A is the dot. Angle F is a single angle mark. So no, they could be congruent. We don't really know that, but it's not guaranteed to be congruent. And angle B, which is the plus sign, is congruent to angle D, which is a dot. Nope. So definitely it's choice 1. All right, let's do number 2. A circle is continuously rotated about its diameter. Okay, which 3-dimensional object will be formed? Well, okay, let me just kind of draw like a circle. I'll draw a diameter. I'll draw it. It doesn't matter which way you draw the diameter, but that's the diameter, right? So it's being swung around this way and coming back in the back of it and coming back. It's just like, I can't really do a good drawing, but it's being spun around the diameter, right? If you do that, you will end up with a sphere. All right, a cone would have a point on the top. A cylinder must have a circle on the top. We have software that I could really use to illustrate this, but for now, just go with me. It's a sphere. Prism, there's no way you can end up with a prism. Prism has edges on it, and we don't have any edges here. All right, so you'll end up with a sphere. Every point over here gets circulated around that diameter, every single point, to the point where you will get a 3-dimensional shape, and that 3-dimensional shape is a sphere. Number 3. if CL is 3.5, oh, let's read the top first. Never miss that part. In the diagram below, triangle CER, that's the big outside triangle. LA is congruent to, not congruent, sorry, parallel to CR. Okay, we know if they're parallel right away that these corresponding angles are congruent, right? So angle A, well, angle LAE and angle CRE are congruent. So that means we have similar triangles. They're similar by angle. So we could kind of split them apart. There are a number of things that we could do here. Let's just read the problem and see where it's going. If CL is 3.5, so that's this piece right here, 3.5. I'm going to erase these angle marks just to like clean up my picture a little bit. We know that they're parallel, so we know we end up with two similar triangles. LE is 7.5, so that's this piece on the top here, that's 7.5. And EA is 9.5. What is the length of AR? Okay, so there are two things we could do. One is called the side splitter theorem. This only works when you have parallel lines like inside of the triangle like that. So I could say 7.5 over 3.5 is equal to 9.5 over x. Basically, I could say the top of the left side over the bottom of the left side is equal to the top of the right side over the bottom of the right side. Right? We could do that because this line right here, since it's parallel to the base, it splits the sides up proportionally. That's what we call the side splitter theorem. Another method that I want to use instead, just because it will always work no matter if the side, if we have parallel lines in the triangle like this. What I'm really trying to say is if, for example, the question said, this is y, this is 9.5, solve for y, then we couldn't just do a ratio like this. We couldn't say the top of the left side over the bottom of the right side, left side is equal to the top line over the bottom. We couldn't do that. So what would always work, no matter how they make the triangle, would be if we just split up the triangle. So let me put back my blue pen. They were asking us to find this, so I'm labeling that X. So here's a top triangle, and here is the bottom one. Not the bottom one, the whole thing. Right, so the top left side is 7.5. The top right side is 9.5. And for the whole side on the left-hand side here, we have to add the 7.5 and the 3.5, which is 11. I really should have a calculator handy here. And this is 9.5 plus x because you have to add both pieces. Hey, Ariana. Okay. So let's actually solve this now. So 7.5, right, which is the left side of the small triangle, over the 11, which is the left side of the big triangle, is equal to, well, since I started with the small triangle on the top, I need to start with the small triangle again. 9.5, which is the small triangle right side, over 9.5 plus x. All right, and once we have this, we could solve this. You could solve this however you like. I hate saying the words cross multiply, but that's pretty much what we're going to do here, just to not complicate things too much. So 9.5 times 11, let me pull up my calculator on my phone. If you're looking for a calculator that kind of mimics a TI-84, there's an app called Calculate 84. It's pretty good. It mimics pretty much anything that I could see. So 9.5 times 11, and we get 104.5. So this is 104.5 equals, I'm going to multiply this way now. Now I'm going to distribute the 7.5 into each thing, because what we really have is 7.5 times 9.5 plus x. Right, so we still have to distribute that 7.5 in. So let's do exactly that. So 7.5 times 9.5 is 71.25 plus 7.5 times x is 7.5x minus the 71.25 on both sides because we have to get the x by itself. That cancels. We remain with 7.5x on the right side. So 104.5 minus that's 71.25, and we get 33.25. Divide both sides by that 7.5, and we get 4.4333. So it says to round to the nearest tenth. And since x is what they were asking us to find, right, the length of AR represents x in my case, well, that's just choice 2. All right, so I'll just write this here for completion purposes, 4.43, and that 3 was reoccurring. All right. I love these problems. You're guaranteed to get something like this on a geometry Regents. Right triangle ABC is shown below. Which trigonometric equation, don't let this word fool you. Trigonometric just means, you know, measurements of triangles. Right triangles, you know, just triangles. Which trigonometric equation is always true for triangle ABC? Okay, so in a right triangle, you have 2 acute angles. Right, since this one is always 90, and the 3 angles in the triangle add up to 180, these 2 over here must add up to 90. So if I make up some fake numbers here, if I told you this is 20 degrees, then this one must be 70 degrees, 70, 80, 90. Yep, because they have to add up to 90. All right, now how many degrees they are, we don't know. It doesn't matter as long as they add up to 90 degrees. And without going into much detail, I'm not trying to like teach this right here. I'm just trying to show you how to figure it out. If you take the sine of one of those acute angles, so let's say sine of C, is equal to the cosine of the other acute angle, A. Right, so sine of C is equal to cosine of A. Or you could flip it, you could say cosine of C, well, that's equal to sine of the other angle, A. So which one is it? Well, here's the thing. Do not use a right angle. All right, so anything with B in here, I'm going to cancel out. I'm going to cancel out this tangent one just because tangent of A is equal to tangent of C. I know that's not true, unless if it was like isosceles or something. I don't really know. Cosine of A equal cosine of C. This could be true if each angle was 45 degrees. Cosine of A is equal to sine of A. Nope. Sine of A is equal to cosine of C. Yep, that's my choice. And you can see that's exactly what we wrote over here as well. I just wrote it backwards. Okay. Remember, if you have any questions, just let me know. I'll try to go back as much as I can. Okay. Let's look at this. In the diagram of triangle ABC below, so just, you know, picture that entire big triangle, right? Because I know you can see all different types of triangles here, but focus on that big outer one. AE bisects angle BAC. Bisect means to cut in half. So if AE is cutting angle BAC, angle B to A to C is this top angle, that means this piece is congruent to the piece right next to it, right? It gets cut in half right there. An altitude BD is drawn. Okay, an altitude forms a right angle with the side to which it's drawn, right? So the altitude will come from a vertex, which is just a corner, and it will be drawn straight down to a side of which it will be perpendicular to. If the measure of angle C is 50, so that's this angle over here, and the measure of angle ABC is 60, so ABC is this whole thing over here, right? Do not think that they got bisected, all right? I know a lot of people might think that. In fact, if you look at it, you can see like this one's a little bit bigger than that one. So I'm going to write the number straight over the line so that we don't get mixed up. So the measure of angle ABC is 60. The measure of FEB is this. Oh, nope. It's not that one. All right, if you don't know how to name your angles, you just start from this letter and you work your way down to E and then straight to B. So F to E to B, which corner is that? That's really this corner right here. So this is what they want us to know. Okay, so immediately I'm going to find angle A because I know that the three angles in the big triangle add up to 180. So that's just 180, right? This is angle A. Is 180 minus that 60 plus the 50. So I'm typing that in. 180 minus 60 minus 50. So that's 70. So I know this entire angle A up here is 70, but remember it gets bisected. So each piece here is 35 degrees. 35, 35. Now, I don't have a real strategy here. I'm just going to find angles until I feel like I could find the angle that I'm looking for. In fact, I think I'm kind of almost done right here because as I'm looking at it, you got to look at, you have to see if you could find some triangles. And I'm looking at this triangle right here, triangle ABE. If this angle is 35 and this angle is 60, well, then the three angles in the triangle add up to 180. I could definitely find that little one right there, right? So angle AEB, which is the same thing as FEB, right? I'm just starting all the way from A this time. So AEB is equal to 180. That's the whole triangle minus the 60 plus that 35 on the top. And let's see what we get. 180 minus 60 minus 35. And I got 85. 85 degrees. Now, these questions, you cannot assume that they're drawn to scale. But just from my experience, I could tell you right now that I've seen like it looks the way how it should look. It looks proportional. Everything looks like it's to scale. But you're not given a protractor on the Regents. You're given a compass, don't get me wrong, but not a protractor. All right. Question number 6. A jewelry company makes copper heart pendants. Each heart uses 0.75 cubic inches of copper, and there's this many pounds of copper per cubic inch. Okay. If copper costs this much per pound, what is the total cost of 24 copper hearts? All right, let's read that one more time. Each heart uses 0.75 cubic inches of copper. Okay, so let's see. 0.75 cubic inches of copper. And there is this many pounds of copper per cubic inch. Okay, so there is 0.323 pounds of copper per 1 cubic inch. All right, so all you have to do is multiply them, but I'm writing it in this way because I want you to see that the units get canceled out here. So now I know how many pounds of copper in one heart, one of these hearts. If copper costs $3.68 per pound, what is the total cost for 24 pounds? Okay, so copper costs $3.68 for every 1 pound. How much would 24 then cost? So you just have to multiply that by 24. All right, so you can see pounds get canceled out here. And ultimately, my final answer will be in dollars. All right, so I took the volume of the shape. I found out how much weight there is by multiplying it by how many pounds in every cubic inch. And now this will give me the total number of pounds. So I have to just multiply it by the cost per pound. And once I have the cost per pound, well, that's how much this is how much money it would cost to make only one. So you still have to multiply by 24. And when you do that, well, let's see. I'm going to multiply, well, really just straight across. There's nothing to multiply on the bottom here. This is over 1. This is over 1. Everything on the bottom is just 1. So it's just 0.75 times 0.323 times 3.68 times 24. And we get $21, and rounded to the nearest cent, it's 40 cents. And that is choice 2. All right, I hope everybody could hear me. Let me just double check my mic. I think so. I think my voice is going through. Okay. In right triangle LMN shown below, angle M is 90 degrees. You can see it in the picture here. MN is 12, and LM is 16. Good. Everything is marked in the picture. The ratio of cosine of n is, oh, this is such a simple problem because you have to know SOHCAHTOA, or at least from my understanding, this is how it's taught in the United States. Ever since I was a kid, this is how I learned it, even not in the United States. Like, this is just all I've ever seen. But it's just a memorization device. Cosine is adjacent over hypotenuse. So if you want to focus on n, right, this angle n, because that's the angle that they're asking us to reference, the opposite side is 16. The hypotenuse is over here, and the adjacent side is here. Ooh, I see. You have to do a little bit of work. They want adjacent over hypotenuse, right? Now we have the adjacent, which is 12. We do not know what the hypotenuse is. But that's easy to do in a right triangle when you know two sides. You just use the Pythagorean theorem. A square plus B square equals C square. And just remember, C is always the hypotenuse. So since that's the thing that we're trying to find, I'll leave that alone. A square and B square, they're interchangeable. So you can put them in whichever place that you want. So 12 square plus 16 square is 144 plus, let's see what 16 square is. That's just 16 times 16. And you get 256, which is C square. Let's add 144 to that 256. You get 400. So 400 is equal to C square. How do you get rid of a square? You square root it. And you end up getting, well, I think that's 20, right? 20 times 20 is 400. Yep. Square root of 400 is 20. Plus or minus, but we don't deal with negative lengths. So it's just 20. All right. So now that I know the side is 20, I need my adjacent over hypotenuse. So that's 12 over 20. That's my choice 1. Okay. Number 8. Here's another one. Let me see what it says. Triangle ABC below DE is drawn such that D and E are on A and B and AC respectively. Okay, great. Doesn't tell me anything that I can't see in the picture. But here I see DE is parallel to BC. That's important because now I know the small triangle on top and the big triangle are similar, which equation will always be true. All right, so literally I'm just going to test these out. AD over DE, so that's from the small triangle, the left over the bottom is equal to DB over BC. No. If they had said AB, because AB belongs to the big triangle, right? I could have said, okay, the left over the bottom of the small one is equal to the left over the bottom of the big one. But they didn't use that whole side. Okay, so not choice 1. Choice 2. AD over DE. Okay, so they use the same two sides here. Is equal to AB over BC. Oh, good. They did use it on this one. This one is always true. let's just check out the others real quick just to see why those may not be true. And really, just stick to the same format that I'm doing here. Just verify that the sides are matching up. AD over BC, AD over BC. Okay, that's getting a little bit weird. So what I want to do is just draw the small triangle and the big triangle real quick. So AD over BC. Okay. The only thing I could think of is if you're going to do this side over that side, the other thing needs to be this side over this side, right? Because then these two must match up on the top of the fraction. Okay, so let's see. AD over BC is equal to DE. No. You see, so like this AD needs to either match with the bottom one there or to the one to the right. And it doesn't match with either one. So AD does not match up with BC. AD does not match up with DE. So right away, that one is off the charts. AD over BC. Okay, they have the same fraction there. Is equal to DE. No, same thing again. Over AB. Nope, nope, nope. Choice 2. Which polygon does not always have congruent diagonals? Okay, a rectangle, one of the properties is that it has congruent diagonals. So let's take that one out because you have to remember they're asking which one does not always have congruent diagonals. A square is a rectangle, but even stronger, right? It has more requirements. A square is a rectangle and a rhombus combined. So a square does not always have it. Isosceles trapezoids do have congruent diagonals, right? That means that the two sides of the trapezoids are the same length. So if you drew that diagonal and you drew that diagonal, they are always the same. So rhombus is the one that does not always have congruent diagonals. The thing you need to know about a rhombus is that the diagonals are perpendicular, right? If you draw a rhombus, which means that it's like a square where all sides have the same length, but once you draw those diagonals, they form a right angle there. That's the one you need to know for a rhombus. All right, and the thing you need to know for a rectangle is that the diagonals have the same length. Okay. If the circumference of a standard lacrosse ball is this, what is the volume of the ball? Okay, ooh. The circumference of a standard lacrosse ball is that. What is the volume of the ball to the nearest cubic centimeter? Okay, so there is something in this problem that's not well said. And I don't know if I'm the only one that's thinking this, but if you have a ball, which is a three-dimensional object, how can you find the circumference of it? Right, circumference is only for a two-dimensional thing. But I could only imagine what they're saying is if you have a ball, right, and you were to like wrap a string around it, right, in the center of it to get that great circle, that circumference is 19.9 centimeters. Not good wording on this problem. Not good wording at all. But okay, so let's go with that. All right, so that's 19.9 centimeters. So you'll pull up the reference sheet. This formula is given to you. The circumference is 2 pi r. Basically, I need to find the radius, because if I could find the radius, then I could calculate the volume of the ball. So if the circumference is 19.9, let's figure out what that radius is. Right? It's divide both sides by 2 pi. And let's see what the radius gives us. So that's 19.9 divided. Now you need to put this in parentheses, right? If you don't put this 2 pi in parentheses when you're doing a division, your calculator will only divide the 19.9 by the 2, and then it will multiply by pi. So you want to tell the calculator, no, you need to multiply the 2 and the pi together, and that's where you're dividing the 19.9 by. So just be really careful with that. 2 times pi, so that's second this thing. Okay, and I got the radius is approximately 3.16718. 56718. Now I'm being a little bit extra here because you never round during the problem. Try not to round, or take quite a few decimals. They want the nearest cubic centimeter, so that's a whole number, but only give that answer at the end. Okay, so how do you find the volume of a sphere? Because a ball is a sphere. At least a lacrosse ball is. At least I hope so. Look at the reference sheet, and you'll see that the formula is 4/3 pi r cubed. So all I'm going to do is substitute my r. So that's 4/3 pi 3.16718 cubed. And let's see what that gives us. And the way I'm going to type this in is I'm going to do 3.16718 cubed first. All right, so I got some decimal. Now I'm going to multiply that by pi. And I have another decimal on my calculator. Then multiply that by 4. And now I'm going to divide that by 3. If we typed it in just the way it is, that's fine too. But I got 133.078 blah blah blah. But to the nearest whole number is just 133. Okay, number 11. Which polygon always has a minimum rotation of 180 degrees about its center to carry it onto itself? And it says minimum rotation. Okay. Always has. The thing is, I'm seeing two answers here. Oh, I missed this word. Minimum. So, because I was going to say, okay, you can rotate a square 180 degrees about its center and it would land on itself. That's true. But that's not the minimum for a square. The minimum is 90 degrees, right? Every 90 degree turn. So a rectangle, that's true. Rectangle, 90 degrees, it will actually end up like this. But then another 90 degrees and it will end up right back onto itself. All right, so that's just a rectangle. Imagine putting a push pin right into the center. How many degrees would you have to spin it? 180 degrees is literally a full 180 degree turn. Half a circle. Okay, ooh, look at this. All right, circle O is drawn below. We always name a circle by the center, so circle O. With secant BCD. So a secant is a line that, it starts from the circle and it goes through. I guess it doesn't have to start from the circle too. It could have gone out that way too. But it goes through the circle. Unlike a chord, which only stays completely inside the circle from end to end. All right. If the ratio of DC to CB, so DC is 4 to CB is 5. So a shortcut for this is just to put 4x, 4 parts, and 5 parts. What is the length of CB? Now, there's a little formula that you could use for this. And we call this, well, I call this we equal we. Right? This happens when the lines are, when you're talking about the lengths of the lines in a circle. When the problem looks like this. So, pick one side. You have two lines. You have AD and you have BD. What's the length of the whole side for AD? It's 24. What's the length of the external part of the line for AD? Well, the whole line is external. So that's also 24, right? So that's really just 24 squared. Equals, now, what's the length of the whole line for BD? Well, that's 9x. You have to add the two pieces. And what's the length of the external part? Well, that's 4x. And this is what we're going to solve. So 24 squared, 24 times 24 is 576. 576 is equal to 9x times 4x is 36x squared. All right, because x times x is x squared. Divide both sides by 36. So we get 576 divided by 36 and that is 16. Nice number. Is equal to x squared. Get rid of the square by square rooting both sides. All right, the square and the square root cancel out. You remain with only x. Square root of 16 is plus or minus 4, but we're talking about lengths, so we're not going to think about negative. In fact, we're not, yeah, we are talking about lengths. Okay, so what is the length of CB? That's this piece. Well, 5 times 4 is 20. Okay. The equation of a line is this. All lines perpendicular to this line must have a slope of, well, the thing you have to know is that perpendicular lines have negative reciprocal slopes. All right, negative reciprocal slopes. Okay, so what's the slope of this line? Let's put it in slope-intercept form. So slope-intercept form is y equal mx plus b, right? So we need to get a y by itself. So we're starting off with 3x. Let me erase that. 3x minus 5y is equal to 8. Get the y by itself, so we're minusing 3x on both sides. Remain with negative 5y is equal to negative 3x plus 8. Divide by a negative 5 on both sides. Every part of it needs to get divided by negative 5. So you get y is equal to 3/5 x minus 8 over 5. Now, I don't care about that 8 over 5. All I care about is this piece, the 3 over 5 part. So that's the slope of the original line. So what's a negative reciprocal of 3 over 5? Well, that means the reciprocal part, you have to flip the fraction around. The negative reciprocal part means that you have to change the sign of it. Since that's a positive 3 over 5, we're going to change it to a negative 5 over 3. Oops, nope, not this one. Negative 5 over 3. Okay. What are the coordinates of the center and length of the radius of a circle like this? Okay, so for this one, we want to complete the square. Let me just erase some of this stuff here. Okay, so we want to complete the square to put the circle into a certain form. All right, so what are the coordinates of the center and length of the radius for this circle? You have to know this formula. It's not a formula, but you have to know the setup. This is the standard form of, I'm sorry, no, this is the standard form for circle. This is what we call, I don't know, what do you call this? You call this a form where you can see the center of the circle very easily. All right, x minus h squared plus y minus k squared is equal to r squared. All right, that's one problem before. H and k represents the center of the circle. R is the radius of the circle. So let's take this thing and put it into this form so that we can easily see the center and the radius. So the first step is to group. Now I'm going to shortcut this a little bit. I'm not really going to show you how to do this. If you want to do this, you have to look up completing the square to find the center and radius of a circle. But the shortcut is just group the like terms. So x squared plus 2x. All right, leave a little room right here for a number. And now let's put the y. So that's plus y squared minus 16y. Leave a little space for a number. Is equal to, now that positive 49, I'm going to minus 49 on both sides. So we end up with minus 49 there. You want the constant over there. I kind of push a loose number there. Next thing we want to do is complete the square. So the completing the square step is b over 2 squared. So b is just this number right here. That's 2. 2 over 2 squared, which is really just 1 squared, which is 1. Now, you'll see that I wrote it four steps for this, right? Don't skip any step because that's where the shortcut comes in. You'll see in a second. This one, this last number here is what we're adding to this side and to the other side. And for the y's, you do the same thing too. So it's b over 2 squared. So the b is the negative 16 over 2 squared. So that's negative 8 squared, which is positive 64. Okay, so that's 64 we're adding over here and over here. Can I write outside? No, I cannot write outside. Okay. So here's a shortcut. You see the number inside right here. That's a positive 1 and that negative 8. Well, technically, you're supposed to factor this and factor that. But the factoring is made easy when you understand that it's really just these two numbers. So what we're going to end up with is a x plus 1 square. And then on the other side, it's the y's. So it's a y minus 8 square. And that's equal to, well, you have to add these numbers together. So that's what I'm going to do on the calculator. 64 plus 1 minus 49. And I got 16. All right, so once you have this, you could really answer the question now. What's the radius of the circle? Well, remember, the number outside is the radius to the second power, right? So this is not the radius, this is the radius to the second power. So you have to take the square root of 16 to get a radius. So the square root of 16 is just 4, right? So immediately I could kind of knock out those choices. And for the center of the circle, well, it's always the opposite of these numbers, right? Because remember, according to the formula, the setup for it, it's a negative h here and a negative k here, right? The minus sign actually has to stay. So the shortcut is just the thing about the opposite of those numbers. So another positive 1, it's a negative 1, another negative 8, but a positive 8. That's the center. Negative 1, positive 8, and a radius of 4. Okay. Here's the other question. Let me see if I could just move. Is it possible to highlight? No, I can't highlight these things and move it. Okay. I think I have enough room over here to do it. Okay. In the diagram below of right triangle, let me use a different color just so it doesn't, get confusing with that. Teal. In the diagram below of right triangle MDL, okay, so that's the whole triangle, altitude DG is drawn, the hypotenuse ML. Remember, an altitude forms a right angle to the side of which is drawn. If MG is 3, I'm going to put in that 3 right there, and GL is 24, what is the length of DG? Okay, so you have to know that these, there's 3 right triangles here, right? There's a whole thing, the big whole thing. It tells you right triangle MDL. So this is the right angle. All right, funny how they didn't put that in there, but it told you altitude DG is drawn to hypotenuse ML. So if ML is the hypotenuse for the whole triangle, then you know this must be the right angle. Okay, so there are 3 similar right triangles. Let's split them up. So here's a tiny one to the left. Here's the medium-sized one to the right. And then here's the whole big one, right? That's the one with the right angle right on the top. So this is the right angle there. This is the right angle there. And if there's a right angle over here, there's one right on the other side of it right there too. So let's put that in. All right, this is a 3. This is a 24. Now, you really have to keep track of your angles here. So for the whole triangle, make one of them a double, right? Just to mark it, just to keep it, intact, just to keep track of it. And the other one, I'm going to make it a single. So let's put them into the right place. So this is a single. This is a double. This is a double. And this is a single. Now, if you look at it right now, you can see that this whole triangle and this one here are similar because they have 2 angles in common. So if they're similar by angle, the third angle must be the same as well. So that means this must be my single one. And you can make a similar argument for this one. So basically the one that doesn't have a mark is really the third angle. All right. And let's just see what else we could fill in. So for the whole side down here, this is 24, 25, 26, 27, because you could add the two pieces right there to get 27. What are they asking us to find? DG. So DG is the altitude. That's X. So I'm going to put that in right here and right here. Now, I could tell right away that we're probably not going to use this triangle because there is only one side given here. Whereas over here I have two sides to use, so we're going to use this one. Okay, so for this one, let's just make the ratio now. All right, when you have similar triangles, you can make ratios. So the single to the right angle is 3. The single to the right angle in the other one is X. Right? So go back to this one that you started off with. So this is double to the right angle is X. Double to the right angle is 24. Cross multiply. Oh, I hate saying that, but that's really what I'm doing. X squared is equal to 3 times 24 is, well, let's just do it on the calculator. 3 times 24 is 72. Right? How do you get rid of that square? Well, you take a square root, so you get square root of 72, and you can see that that's right there. Okay. Segment AB is the perpendicular bisector of CD at point M. What statement is always true? So here's my segment AB. The segment AB is the perpendicular bisector of CD. Ooh, okay. So AB is doing the bisecting. It bisects CD at point M. Okay. So I'm just going to erase this. And I'm going to make this segment here CD instead. All right, so this is my segment CD. And AB is perpendicular and bisecting it. So that means it goes down the middle. It forms a right angle. This piece and that piece are congruent. Okay. And they call the point right in the middle here M. Because that's where it bisects it. Which statement is always true? CB. Oh. Let's call this A and let's call this B. Now, just to stress, because I think I know where this problem is going. I'm going to make this line a little bit longer. I'm going to call that B. Because most people think, okay, the perpendicular bisector, you know, is nicely like centered, cutting the other line. But that's not necessarily true. We don't know how long AB is. What statement is always true? CB is congruent to DB. I think that's always true. But let's just see other choices. CD is congruent to AB. Not true. Right? Clearly by my over-exaggerated picture here. That's why I over-exaggerated it, to point out any little misconceptions that we might have. Triangle ACD, okay, so that's this top triangle, is similar to triangle BCD. BCD. I can't say so. Right? Because to be similar, you need to have at least two angles that are congruent in each. And if I make a triangle on the top and a triangle on the bottom, they may not have any angles in common. ACM, so that's this little triangle here, is congruent to BCM. No, same thing, right? I don't know how long this line goes. We're not going to have any other angles. It's definitely choice 1. Okay, let's do 17. Let me just take a quick look, check out my stream. I hope everything is going through just fine. It looks like it, though I'm not sure. Okay. In the diagram below, circle O. Okay, AC and BC are chords. Okay, we could see that. right? AC is there, BC is there, and this angle is 70. Okay, if OA equals 9, so that's this piece here, that's 9. The area of the shaded sector of AOB is, okay, so the area for shaded sector is really just a percentage of the actual area. Now, let's see how we're going to figure that out. This is an inscribed angle because it's on the circle like that. So if this is 70, there's a relationship between the inscribed angle and its intercepted arc. This intercepted arc is twice as much as that angle. So this is 140 degrees. Now, we know that's 140 degrees of a full 360 degrees. So that's the percentage of the circle's area that we want, 140 out of the 360. All right, so if we want the area of that sector, it's just the percentage of the circle times the full area of the circle. The full area of a circle is pi r squared. The radius is 9, so that's really just 140 over 360 times pi 9 squared. And that's what I'm going to type into my calculator right now. I'm going to do the 9 squared first, which is 81. Multiply that with pi. And now we're going to multiply that by 140 divided by 360. And we get 98. Oh, I just noticed the answer is in terms of pi here. So you know what I'm going to do? I'm going to redo that, but not type in the pi. Okay, so 140 divided by 360. Multiply that by 81. And I get 31.5 exactly. So 31.5, and we leave the pi alone. And we can see that is choice 4. All right, we're getting down to the end of the multiple choice here. Quadrilateral BEST has diagonals that intersect at point D. Which statement would not be sufficient to prove quadrilateral BEST is a parallelogram? Okay. I'm just going to draw something that looks like it. All right, so this is BEST. It says it has diagonals that intersect at point D. It's going to draw those two diagonals, call that point D. Which statement would not be sufficient to prove that it's a parallelogram? All right, so there's certain things that we know about parallelograms. Opposite sides are congruent, opposite sides are parallel. The diagonals bisect each other. All right, that's another one too. So let's see. BD is congruent to SD. Okay, that's true. And ED is congruent to TD. That is true as well because they bisect each other. All right, but let's check out the other choices real quick, because I'm not sure if that's enough to show it's a parallelogram. I think it is though. But let's see. BE is congruent to SD, so that's this side congruent to that side. And ES, the bottom side, congruent to TB. That's the top side. Oh, they want to know which one would not be sufficient enough. Okay, so it seems like choice 1 and choice 2 are, right? Choice 2 is basically saying opposite sides are congruent. Choice 1 is saying that the diagonals bisect each other. Let's check out choice 3. ES, which is the bottom side, is congruent to TB. Okay, so these two sides are congruent. And BE is parallel to TS. Ooh. I have a feeling it's choice 3, but let's just check out choice 4. ES is this side parallel to BE, and BE is parallel to TS. Okay, so this one is saying opposite sides are parallel. This one is definitely enough. It is choice 3, but just let me show you a counter example why. ES is congruent to TB. That means the top side and the bottom side have the same length, right? ES is congruent to BT. Okay. Let me erase that. Hold on. ES is congruent to TB. So that's the bottom line congruent to the top line. Okay. And BE, so that's this side, is parallel to TS. Huh, hold on. I think, nope. Let me show you the counterexample. Now I'm understanding it. So I could draw a shape where BE and TS are parallel to each other, right? So this side is parallel to that side, right? That's BE and TS. They're parallel. So I met this requirement. But look at this. ES, which is this piece, is congruent to TB, which is that piece. That's a trapezoid. You could get a trapezoid from choice 3. So that's definitely not enough to show that it's a parallelogram. Okay. Number 19. The equation of line T is this. Line M is the image of line T after a dilation with a scale factor for half centered at the origin. What is an equation of line M? Let's read it again. Sorry. The equation of line T is this. Line M is the image of line T after dilation, with a scale factor for half centered at the origin. So the thing you have to know is the center of dilation, which in this case is the origin, is it on this line? Because if it is, then when you dilate the line, you're actually going to get the same line. If it's not on the line, then you get a parallel line. Those are the only two possible choices. Is it the same line or parallel line? Well, here's how you check to see if the origin, or any point if they gave it to you, is on this line. So the origin is the point 0, 0. So just substitute 0 in for x here. So this will be 3 times 0 is 0 minus, well, y is 0. So that's 0. 0 minus 0. Is that equal to 6? If it's a true statement, then you know the center of dilation is on the original line. Since it's not a true statement, we could say that the center of dilation is not on that line, so you will get a parallel line. I'm looking at the choices, and I see that the choices are in y equal mx plus b form. So let's take this original line that they gave us, that you're going to dilate, and put it in that form. So minus 3x on both sides. You'll end up with negative y is equal to negative 3x plus 6. Get rid of that negative sign in front of the y by dividing everything by negative 1. So that's 3x minus 6. Okay, so this is just the original line. And, well, if the scale factor is a half, you can only do this when the center of dilation is the origin. Since the center of dilation is a half, all you have to do is multiply the y-intercept by a half. All right, so what's a half of negative 6? That's y equal 3x minus 3. So that's choice 4. So just keep in mind, when you're dilating a line, it must have the same slope. That means that they must be parallel. So it could not have been this or this. It had to be one of these two. And, well, in this case, it was just 4. I guess they try to trip you up with by just changing the sign there. Okay. Question number 20. Only 24 questions on the multiple choice section. So far, I have to say this isn't too bad. A cylindrical pool has a diameter of 16 feet and a height of 4 feet. Let's draw that. So cylindrical pool. I don't think I've ever seen well, I'm lying. I have been in one before. Cylindrical pool has a diameter of 16 feet. So I know they're giving me the diameter, but I'm writing the radius, right, which I think is more useful for our formulas that we have, and a height of 4 feet. Okay, so this height, so this picture is actually, it's good, but you could clearly see, right, if this is 8 feet, how on earth is this 4 feet? This is way longer. So in reality, I should make my pool a little bit shorter. Maybe I should have like drawn it up to there, but whatever, right? You get the point. The picture is not drawn to scale. The pool is filled to half foot below the top. Okay, so it's filled like, let's say, up to here, right? This is the water line. Okay, how much water does the pool contain? To the nearest gallon. Okay, and we're going to find the volume, the regular volume, in feet, because when we find the volume, it will be in feet. But then we have to convert it to gallons. All right, thankfully we have a nice little conversion chart right here. All right, so in reality, I'm really finding how much water does the pool contain. I'm only finding this part of the cylinder, right? So forget the top part of the cylinder. If this is a half feet right here, then from here to here is 3.5 feet. So this is 3.5 feet. Okay, so same cylinder, same radius, right? Even though it's water, this radius is still 8 feet, but it's only going up to 3.5 feet. So how do you find the volume of a cylinder? Well, you look at the reference sheet and you'll see that the volume of a cylinder is the pi r squared, which is the area of a circle, times the height. And that's all it is. So that's all we're going to type in. Pi, we'll leave the pi alone. The radius in this case is 8, so 8 squared. And the height is 3.5. Okay, so I have my calculator in hand, and I'm going to type that in. 8 squared is 64 times 3.5 times pi. Whoops, I just pressed clear. 64 times 3.5 times pi, and you get the volume to be 703.71675, and a bunch more numbers, but never round so soon, always round at the end. And this is in cubic feet. So if this is the volume in cubic feet, but we know that every cubic foot has 7.48 gallons, well, just multiply this number times 7.48, and that's exactly what I'm going to do. Multiply by 7.48, and I get this number right here. Okay. Question number 21. The area of triangle TAP is 36 square centimeters. So I'm just going to draw a triangle. The area is 36 square centimeters. A second triangle, Joe, is formed by connecting the midpoints of each side of TAP. Ooh, what is the area? Okay. All right. So I'm just going to, let me erase this and make it a little bit nicer. So this is my original triangle, TAP. And if we are going to make a triangle connecting the midpoints of this triangle, well, you get another triangle here, and this is what they want to know. What is the area of this triangle? Now, so here's the thing that you need to know. Let me use a red color just to highlight. This side is half the length of AP, right? And then you can say the same thing for the others. So this side is half the length of that, and this side is half the length of that side. So what I'm trying to say is this small triangle here is similar to the big triangle, but just all the sides are cut in half. So here's my big triangle, TAP, and it got smaller, right, to that small triangle. They're similar, but the scale factor is a half. If you're checking up the perimeter or something, if you know the perimeter of this, all you have to do is say, okay, well, the other one is half the perimeter, right? Perimeter is just the length around the sides. The area doesn't work the same way. The area is scaled by the scale factor to the second power. All right, so that will be the area of the new one. So if the area of the big one is 36, then, and the scale factor is a half, that's really just a half square of this area, and this is what will give you the answer. So a half square is a quarter, and a quarter of 36, well, 36 divided by 4 is 9. All right, so the area of that little triangle is 9. Okay, okay. Number 22. On the set of axes below, the endpoints of AB have coordinates blah and blah. If AB is dilated by a scale factor of 2 centered at 3, 5, let's make the point 3, 5. 1, 2, 3. 1, 2, 3, 4, 5. So that's right here. Okay. What are the coordinates of the endpoints of his image A prime, B prime? So scale factor of 2. Okay. So here's what you really need to do. You need to, like, if you had a ruler, you connect this. Ooh, that's actually a really straight line for me doing this by hand. And you multiply that distance by 2, right? So like it will end up like, if I could extend it, I will. And in fact, I'm going to. But since I don't have a ruler, look at how I'm going to do this on the graph paper, because the graph paper is kind of like a ruler. So I'm going to count 1, 2, 3, 4, 5, 6, and 1 down. But the scale factor is 2, so I'm doubling it. I'm going to do it again. 1, 2, 3, 4, 5, 6, and 1 down. So A prime actually lands right here. Oh, I had to have a steady hand for that one. Right? If you had a ruler, you could literally just make this line as long as you can. Right? Just check this up in centimeters or something, multiply by 2, and see exactly where that ended up. But you could also just use a graph paper like that. So without doing it for the other point, without like drawing the line for it, I'm just going to do the counting method that I was using before. Just erase this because that's an accident. So from my center of dilation to B was 1, 2, 1, 2, 3. So 2 to the right, 3 down. So I'm just going to double that. 2 to the right, 1, 2, 3, 3 down. This is my B prime. And here's a good way to check to see if you actually did that right. If you connected A prime to B prime, you should, oh boy, you should get a line that's perfectly parallel. All right, so if you find like you're drawing that line and it's not parallel to AB, then you know you made a mistake somewhere. So let's see. What are the endpoints? So the endpoints are 1, 2, 3, 4, 5, 6, 7, 8, 9. That's -9, +3. -9, +3 right here. I just looked at one point, A prime, and it was the only one that had -9, 3. So easy peasy. Okay, 2 more problems. In the circle below, AD, AC, BC, and DC are chords. Great. EDF is tangent at point D. AD is parallel to BC. Okay, AD is parallel to BC. Which statement is always true? Angle ADE is congruent to angle CAD. CAD is this one. No. Nope. Nope. That's not true at all. I don't see why that would be true. I think they try to like trick you with the parallel lines. Like they're looking for alternate interior angles or something. And that's not true. So let's cross that one out. Angle CDF, so CDF is this one over here, is congruent to angle ACB. ACB is this one. Nope. Again, I don't know why they are saying these things. BCA is this one. Okay, I'm looking at the alternate interior angles. I didn't even look at the other piece, but if they say CAD or DAC or something, I know that's true. BCA is congruent to angle DCA. Oh no, they did DCA, which is this one. That's not true. I don't know if that bisects each other. Okay. It better be choice 4, otherwise I'll have to recheck those choices. ADC, A to D to C is this one, is congruent to angle ADE. Okay. I don't know if that's true. So I guess I'll have to recheck these choices. All right, so this is the first one I got a little bit stumped on. So let's take a second. Let's back up and let's reread this again a little bit better because there might be something that I'm missing. In the circle below, AD, okay, chords. EDF is tangent to point D. Okay. All right, that means it just touches it right there. And AD is parallel to BC. AD is parallel to BC. Which one is always true? Angle ADE, which is this one. Okay. Is congruent to CAD. Would that be true? Could that be true? CAD. No, I don't see why. CDF, okay, which is this one out here, is congruent to angle ACB. Hold on. I think this is the right one. Angle CDF. Okay, because this angle is half of this arc. But this angle is also half of that arc. But this angle and this angle are congruent. Wow. Okay, so I found the right answer here. And I'll just explain that to you real quick. Why it's choice 2. I was expecting the answer to be a little bit simpler, but you could expect that question number 23 is going to be a little bit more difficult. So CDF, this angle is half of the intercepted arc right here. But an inscribed angle is also half of the intercepted arc. So this angle and this angle are the same. But then because these lines are parallel, parallel lines cut by transversal forms congruent alternate interior angles, so those two angles are congruent. Okay, let's do the final multiple choice question. Okay. In the diagram below of triangle ABC, D and E are midpoints of A and B respectively. Okay. And DE is drawn. Which methods can be used to prove triangle ABC is similar to ADE? Okay. If this is a midsegment, a midsegment is a line formed when you connect two midpoints. So midsegment is parallel to the other side. So if they're parallel, I know that this angle here and this angle here are congruent. And the same thing for these two. All right, so I know I could use angle to show that they're the same. Which methods could be used? So I know I could cross out choice 2 for sure because it doesn't have angle. Side similarity. That means that the three sides are proportional. Yes, I could use that too, because if D is a midpoint, this piece and this piece have the same length. So that means AD is half of the whole length there. AE is half of the whole length there. And then DE, a mid segment, is also half of the opposite side. So I could say that all the sides of ADE are half the lengths of all the sides of the big one. So I know for sure that we can use side. So I could cross out choice 3. Now let's see, side, angle, side. Yeah, you could use side, angle, side as well, because if I could prove that all the angles are the same, and I could prove that all the sides are proportional, then I could just take a combination of any of those that I want, right? Like, let's say this angle I know is congruent to this one. Let me just erase some stuff. Okay. I know that these two angles are congruent. I know that this side is half of that side, so that's 1s, right? I proved an A already. All I need to prove is one more s. Yes, if it's a mid-segment, this side is half the length of that side. So I could use side angle side similarity to show that they are similar. So it's actually choice 4. Use all 4 of those strategies. Whoops, didn't mean to do that. And there you have it. Those are the multiple choice questions for this test. Most likely I will go over the long answers tomorrow. I've been here for 1 hour and 15 minutes, so I'm going to end it right here. And yeah, hopefully I see you tomorrow. Bye-bye.